Let's say this is the list or this is the array that we are going to sort using merge sort. So let's create a function merge sort, and in this function we're going to be passing this list that we're going to sort using this function and the lower bound of this list and the upper bound. Now here we are going to find out the midpoint. So we check if lower bound is smaller than upper bound, then we calculate the midpoint. Here midpoint will be lower bound plus upper bound divided by 2. So let's do math.floor, and here lower bound plus upper bound divided by 2. So this will be the midpoint, and we are going to do everything inside this if. So we are going to do only if the lower bound is smaller than upper bound. Now we are going to recursively divide this list into two halves, and we're going to sort them. So first half will start from lower bound to mid index, and the second half will start from mid plus 1 to upper bound. So here list, and here it will start from mid plus 1 and end at the upper bound. Now we're going to merge these sorted halves with another method, merge. So we're going to create and call another method, merge, and here inside this function we are going to pass the list, the lower bound, the midpoint, and the upper bound. So here let's create this function, merge. Now function merge, and let's pass the parameters. Let's write list, lower bound, mid, and upper bound. Now inside this we need to create two temp arrays, left and right. So left will be of size m minus lower bound plus 1, that is mid minus lower bound plus 1, and the right one will be equal to, the size of right one will be equal to upper bound minus mid, right? Now let's create these temp arrays. Let's say first is left and the other one is right. Now we're gonna copy the data into these two arrays. So for I, where I start from 0 and it goes till n1, which is the length of left, I plus plus, and then we add lower bound plus ith element from the list to the left array. So here lower bound plus I. Similarly, we add elements after middle point to the right array. So its length is n2, and here let's say right, and this will be mid plus 1. So we're gonna add the elements after the midpoint in this right array. Now we merge the data of these array to the final list. So let's take I, initialize it with 0, j, initialize it with 0, and k, which will start from the lower bound, as this is the pointer for the final list or for the final array. And now we take a while loop where I goes till n1, which is the bound for left subarray, and j goes till n2, which is the bound for right subarray. So these are the two pointers that we're taking here. Now we put elements into the solution array or solution list from these subarrays one by one. We check if the element in left is less than the element in the right subarray. If this is true, then we put the smaller one, that is the element in the left, into the solution list or in the solution array, and we increment I. And if not, then we put the element from the right array and increment j. And out of these if else we increment k that we are using for iterating through the merged array. And then if there are remaining elements in, still there are few elements left in left subarray, then we copy them. So if there are still elements in the left subarray, so we're gonna put these remaining elements. So until the I does not reach to n1, we're gonna put all the elements present in the left subarray into the final list. And here we will increment I and increment k each time. And the same we will do for the right subarray. After inserting or after putting all the elements of the left subarray, we're gonna put all the remaining elements of the right subarray into the final or the solution list. Oh, this is right, and here it is J, and with each iteration we increment J and K. So this is the implementation for merge sort. Now we're gonna invoke this merge sort function to sort this list. So first let's get the length of this list. Let's call it len. And now let's invoke function merge sort. And let's pass this list. And the lower bound for this is 0, index 0, and the upper bound is length -1. And after sorting this list, we're gonna print this list on terminal. So let's say console.log list. That's it. Now let's save this and now run this program. So here let's say cd divide and conquer, and here inside divide and conquer node merge sort. So this is the sorted list that we're getting: 2, 3, 6, 9, 11, 14, and 66.